Hello my dear student, today we are in lecture number 13. Okay, and as I promise you that today lecture will start with the shortcut how to find the position vector directly. Alright, okay, first let me write here the lecture number 13, and what we are studying actually, it is the vector analysis. Alright, yes, this is the 13th lecture. Student, in last class we studied the position vector, and I told you how to find directly the position vector. Okay, for this shortcut, let me draw here the 2 points P and Q with this origin. This is the y-axis and x-axis. This is the one vector and this is another vector. All right, here x1, oh my god, it is x1, y1, x2, y2. All right, yes, this is the point P and this is the point Q. If I wish to find the position vector Q, PQ, that is the position of here PQ, position of Q with respect to P, I'm going to find here. So the shortcut I'm giving you, remember this was the R, na? This was the R1, as the R2. R must be written as, what is this R? R actually the required result, what you want and what you have to find actually. So the R must be written as head minus tail. Remember, directly you can write without using triangle law. You have to write head minus tail. Okay, head minus tail. And what is the head minus tail? Actually, you have to subtract head minus tail, that is the coordinates. Here, try to find out the head and then tail. If you are finding for the position vector R, then find out the position vector R over here. What is head? The second coordinate. And what is the tail? Here the first coordinate. So directly you can write R as head, it is x2 minus x1 I cap plus y2 minus y1 j cap. Now my dear students, you can find this was the result we obtained using triangle law. Directly you can write. If someone asks what is QP, okay, QP, it means now head is which one? P is head and Q is tail. So you have to subtract head minus tail, it is x1 minus x2 I cap and y1 minus y2 j cap. Okay my dear student, yes, in this way. Okay, let me do some very easy practice. The Q. Now I have to do much hard work to write the question. I hope you don't have to do very hard while finding the answer. Quickly you will give the answer, I know that. It is, suppose 2, 5, here I am giving you the 4, 5, and this is suppose 5, 1, 5, 1. This is the point A, B, C. Now I'm asking the question, find position vector of the first one, position of B with respect to A, B with respect to A. Yes, try to solve. Hurry up student, try to solve, and then I will write, you will match your answer. Pause the video and try to solve. Position of B with respect to A, the second one. Position of A with respect to C. Hurry up, try to solve my dear student. Hurry up. Okay, and remember you will represent over the diagram this one. Pause the video and try to solve. Okay, let me solve now. Position of B with respect to A. Position of B with respect to A, arrow will be in this direction. Remember, position of A with respect to C, position of A with respect to C, the arrow will be in this direction. Now, for this one, the head is which one? B, and tail is A. Okay, so the answer is, let write it is a vector A. Now, head minus tail, here the head, 4 minus 2, it is 2i, very simple. 5 minus 5, it is 0j, gone. Alright, so this is the answer. Very good, very simple. Now, this position vector, so here let it is R also. Now, head is A and tail is C, so the head 2 minus 5, it is minus 3i. Alright, minus 3i plus head 5 minus 1, it is 4j. Answer. The quite very simple, na? Yes, in this way you can find out the position vector, head minus tail. So remember this shortcut, my dear students. Okay, now let me wrap this one. We'll start today's lecture with the first topic. Actually, it is Lamy's theorem. The 13th lecture, starting with the very important topic, it is Lamy's theorem. And this is called the condition of zero resultant. What are the conditions to find the zero resultant? Okay, we are going to study the condition of zero resultant. Okay, we are going to find out the condition of zero result. My dear students, as you know that if it is written vector A plus vector B and plus vector C, it is 0, then how you will represent this particular thing using the diagram. Okay, so using the diagram, suppose this is the vector A, this is the vector B, and this is the vector C. Alright, A, B, and C. Now you can find out here we don't have the resultant. Actually, the displacement is 0. The vector start from which point? From here and end at here. Okay, all are in same flow, so the displacement 0, it means the resultant will be 0, and this could be written as the null vector. All right, now try to locate this all the vectors from the same point. Okay, we are going to arrange all the vectors from the same point, and then you will be able to understand, yes, it will be 0. Suppose a very simple thing. Okay, try to understand. If I am just holding here the two thread, all right, this one and this one student pulling the thread from here, one student pulling the thread from here. So now the third student have to pull this thread so that this remain in rest. How he should pull? He or she should pull. If he or she should pull this point, okay, using a thread in this direction, whether this will be in rest? No, this will be not in rest. The resultant will not 0. If he is pulling this way, then also the resultant will not 0. Of course, you will say, yes sir, that student should pull in this direction. It could be the 0. If the two are pulling in this direction and the resultant of these two are equivalent to this one, okay, magnitude is equivalent to this one, and then it is in opposite direction, then it could be in stable state. That is, it could not be moved at all. All right, my dear student. Now, this is the specific. So we are going to represent this one from the same point, as this was the same point. What is the meaning of same point? It means the way of action of all the vectors should be same. It means either all the vectors are moving outward or it is coming inward. The way of action should be same. Now we are going to draw this one. Okay, look at here. This was the A, okay. Now the B is moving down, so let me draw here the B. Now the C is going in this direction, so from this point the C will go in this direction like this way. Okay, now you can see, my dear student, yes, this could be the zero. It means if any point is there, this point will not move at all. It could be, it's not necessary, but it could be. If this condition fulfill, a plus b plus is 0, then it remain in rest. Okay, and this particular thing, what I'm telling you, this particular thing was explained very well by Lamy. Okay, and that is considered the Lamy's theorem. You have to study in mathematics also, and that Lamy theorem will help you a lot in mechanics. Okay, it will help you to solve the number of questions without wasting your time. So without wasting the time, we move for the theorem, that is the Lamy's theorem. Let me wrap this. Why actually I have given here the 2 to 3 minutes over here to explain this one, because my dear student, you should realize what we are going to do. Okay, you should realize, and this physics is actually the practical thing. If you are studying the physics and physics does not dancing before you, it means you are not actually studying the physics. All the things that you are studying, it should be dancing before you. Yes, this is happening. Okay, and always try to relate with your life. Always try to see, visualize in, okay, in your real life if you want to really learn it. Now, the Lamy's theorem. Lamy, the name of mathematician was the Lamy, so this is called the Lamy's theorem. Okay, first, my dear student, I'll tell you, Lamy find that this particular theorem has certain conditions, okay, to apply. What are the condition? You should write one by one. It is the condition. You cannot use Lamy's theorem everywhere. Okay, so what is the condition? So the first condition, I hope you are writing in your notebook. Kindly write down. I'm not writing over here on the board. Actually, I'm telling you. So the first condition, it is forces should be concurrent and coplanar. Okay, forces should be concurrent and coplanar. I will explain, my dear student, what is meaning of concurrent. Okay, if two or more than two forces are living from the same point, okay, are touching at the same point, then that forces are considered as concurrent. For example, look at here. All the forces are touching this point at the same point, so this forces will be considered the concurrent forces. Okay, these are the considered the concurrent forces. Now, and you know about the coplanar. So what was the first point? Forces should be concurrent and coplanar. This is the first condition. If forces are not concurrent and not coplanar, you cannot apply Lamy's theorem. Remember, the second point you should mention as a condition. Bodies on which forces are acting should be in equilibrium. This one is very important, my dear student. Again, I'm telling you, bodies on which forces are acting should be in equilibrium. Of course, this Lamy's theorem is applicable for equilibrium only. Okay, body should be in equilibrium. It means the body is not moving at all after applying, even after applying the number of forces. Now, the next condition. Remember, three forces must act and way of action should be same. That is either away or towards. Okay, all the forces should be in same action. And remember, this Lamy's theorem is applicable for only three forces. You cannot use more than three forces. You cannot use less than three forces. Three forces should be there to apply the Lamy's theorem. Now, you should write the statement of Lamy's theorem. So the statement is, according to this theorem, under above condition, what we have mentioned actually, okay, under above condition, each force is proportional to the sine of angle between other two forces. Full stop. This is this statement. Now we are going to study this Lamy's theorem. What is Lamy's theorem? All right. So look at here, my dear student. You are having three forces, F1, F2, F3, and all the forces are making the angle here. The three forces I am drawing F1, F2, and F3. Okay. Suppose the angle made with F2, F3, it is theta 1. Angle made between these two forces, it is theta 2. And angle made between these two forces, suppose it is theta 3. And this point, this one is very important, my dear student. This point O is in equilibrium. If O is in equilibrium, okay, what does the meaning of equilibrium? Equilibrium, it means net force is 0. Vectorially, we'll write F1 plus F2 plus F3 is equals to how much? It is 0. If F1 plus F2 plus F3 is 0, then only we can apply this Lamy's theorem. Alright, and this Lamy's theorem tells you the ratio of forces with the sign of angle. Okay, it is proportionate. So F1 divided by remember this is the force, and for this force the opposite angle is theta 1. So the sine theta 1, this will be equal to the F2 by, now try to find out the angle opposite to this F2. It is theta 2. So here the sine theta 2, it is equals to F3 divided by F3, opposite angle is the theta 3. So the sine theta 3. This is the Lamy's theorem. That's it. Okay, this is the very simple Lamy's theorem. Now this is very important. Sir, kindly give a question for the practice where this should be used. Okay, without knowing the use of any theorem, any particular topic, it is okay totally wastage of our time. So let me do here a question. Suppose this is the ceiling, and from the ceiling, using 3 thread, I've tied this thread with the ceiling. The ceiling, let me continue. Okay, yeah, that's the ceiling. Okay, mass is suspended. Suppose it is 5 kg. This one is suspended. Now if you are known about the angle, okay, suppose this is 60 degree, this is 30 degree, you are known about this one. Then question is asking, if this thread is okay pulling this 5 kg, it is suspended 5 kg, of course this both the thread will experience some force or not? Yes, this will experience some force. Later on we will study this force known as the tension. But here try to understand, suppose this thread is experiencing a force F1 and this thread experiencing a force F2. Alright, you have to find this F1 and F2. How you will find? Using Lamy's theorem, this is very simple. You have to find this force F1 and F2. Okay, and this is quite obvious. Here the force, if it is F3, it is equals to the force acting by this 5 kg. And how much force it is acting? It is mg, that you have studied in your standard 9. This is not very difficult, my dear student. I can write this mg if we use the value of g as 10 meter per second square. So this will be equals to 50 Newton. Yes, am I right? Yes. This will be the 50 Newton. Now, using Lamy's theorem, what we'll write? Remember, to apply the Lamy's theorem, we need all the angle opposite the forces. So, against this force, if it is F3, alright, against this force, the angle is this one. And how much this angle is, my dear student? It is 90 degree. You can see it is 30 and 60, so the 19, and over the straight line it should be the total 180, so it is 90 degree. Okay, now we have to find this angle opposite to F2. This is the total angle. Okay, and this total angle, since it is 90, okay, since it is 90 and it is 60, so the total angle will be 150. All right, yes. Now against this F1 we have to find this total angle. Since it is 30 and it is 90, so it will be 120. Okay, so successfully we find all the angle. I hope if you student mathematics, then this is not very difficult. Now what we have to write? We have to write the ratio. Okay, I'm writing diagonally, my dear student. Okay, let me write over here. Let me grab this one. I'm having the space. Okay, now F1 by sine 120. F1 by sine 120 is equals to F2 by, here the F2 by sine 150 is equals to F3 by sine 90. Okay, this is entirely known value. F3 you are having 50 Newton and sine 90 it is 1. So you can write here the 50 by 1, it is 50 Newton. Alright, you are having the value of this one. Now comparing this to, could you find the value of F1? Yes, because you are having the value of sine 120. Sine 120 you can find by sine 90 plus 30. Remember students, sine 90 plus 30. In this way you can find the value of sine 120. But you should remember directly the value of sine 120, sine 150. Okay, but here, could you find F1? Yes, we can find here the F1 over sine 120. It is equals to how much? It is 50. Now this is known and this is known, then you can find the value of F1. In similar way, comparing this one with this, you can find the value of F2. That is F2 by sine 150, my dear student, it is equals to 50. Okay, so sine 150 will give you the same value, and the F2 is equals to 50 times sine 150. In this way you will be able to find F1 and F2. I hope you understand, my dear student, Lamy's theorem. Okay, now let me give you a homework. Okay, for the on the basis of this Lamy's theorem, what you have studied. Let me grab this one. Again, my dear student, you have to find some force using Lamy's theorem, and this will be your homework I'm giving you. Here from the ceiling, my red hot ceiling, one thread I use and a mass is suspended. Here a force is acting. Of course, if you will tie a thread over here, this was suspending like this way, but if a thread is tied in between and pull in this way, then the diagram looks like, okay, it is 10 kg. All right, you have to find this force. How much force applied over here so that it bent at 60 degree. Okay, remember, if you will increase this force, this angle will decrease. If you will decrease this force, this angle will increase. But the question, how much force applied by this one so that this angle should be 60 degree? This is the question. And also find the force in this string. You have to find. Okay, this is your question, my dear friend. So this is the question over the Lamy's theorem. Now let me move for the next topic. Now, my dear students, we are going to start here one more important topic. It is the multiplication of vectors. Okay, we are going to start today the multiplication of vector, and this particular topic will be the last topic of vector analysis, and this last topic will, I think, finish in last class, or might be it will take 2 more lectures. Okay, so here multiplication of vectors. Multiplication of vectors. Remember student, I have to teach you in very detail. I have to teach all the things. I don't have to finish the syllabus. You should study in proper way, my dear students. Again and again I'm telling you, you have to solve my assignment. Okay, and whatever maybe you are having the books, you can solve. And the very important book, it is the S.C. Verma, okay, Harishchandra Verma. That is the very famous book. You should just go with that book always. After my lecture, you should see that S.C. Verma book. Now you can buy that book from the market, my dear students. Remember, for any good student, this is very important to finish one book entirely. Remember, you are not touching many books, but none of the book is completed entirely. One book should be completed entirely. Okay, for your satisfaction, you can take NCERT even. Okay, but you should complete one book entirely to build up your confidence, my dear student. Here, multiplication of vector. My dear students, the multiplication of vector, it is of 3 kinds. Okay, one, it is multiplication of vector by magnitude. Okay, by magnitude. By magnitude. All right. And multiplying any vector by magnitude, the result will be vector. Okay, remember, the result will be vector. The second, multiplying any vector by vector. By vector. And multiplying any vector by vector, these are all 2 kinds. Okay, yes, these are all 2 kinds. One, it is called the dot product. Dot product. And second one is called the cross product. Cross product. Okay, this dot product will give you the resultant, that is the result, as a scalar. Result will be a scalar, that is the magnitude. Okay, this will give you the result scalar, and this will give you the result as vector. It means if you will find the my dear student, I hope you are not able to see this one due to the focus, but I have been written here the result. Okay, result, and then after arrow, and then it is the vector. In same way, I have written here the result, I have written here the result. Okay, my dear student, so the result will be the vector. My dear student, if you will do the multiplication of a vector with the vector, it could be scalar or it could be the vector. Try to recall, you have studied in standard 9th the formula of work done. Okay, the formula of work done, and that formula gives when you multiply 2 vector quantity, force and displacement. Even you eagerly ask with your teacher also, so why it is happening? So you will learn over here. If you multiply the force with the displacement, and both the force and displacement are the vector quantity, but what you got as a result? You got as a result work done, and that work done is a scalar quantity. So if you multiply 2 vector, okay, it could be scalar or vector. It depends on certain things that we will study. Okay, but if you will multiply a vector by a vector, it could be vector also. And if result is scalar, then this is called the dot product or the scalar product, because the result is scalar, that's why it is also called the scalar product, and the result is vector, that's why it is also called the vector product. It means cross product having the name vector product also. Okay, So let me start today's lecture with the multiplication of any vector by magnitude, and then we'll start the lecture next lecture by the dot product and cross product, my dear student. Here the first one, let me finish this one because it will not take much time. The first one, multiplication by magnitude. Multiplication by magnitude. Okay, yes student, if you will multiply any vector, suppose this is the vector n a with the number n, what you will get? Na. The very simple, if you are having this vector a, okay, it means na will be little longer. Okay, this is n times a. So simply it will increase the magnitude. If you multiply any vector by the number or the magnitude, so simply it will not affect the direction, but it will increase the magnitude of the vector. This is only. Alright, for example, if you are multiplying 5 with a vector a, then you will find 5a. Very simple. The next example, if you are multiplying this 2 by the I plus j, what you will get? You will get 2i plus 2j. The very simple. I hope you understand. Okay, if you will multiply this 2 with the I plus j, you will get 2i plus 2j. It means the number is not going to disturb the direction of any vector. The number, it will only increase the magnitude. Okay, if the vector a was of this length, then n times a become of this length. So the magnitude is being increased, but remember, my dear students, the direction is not going to be changed. And the quantity, if you multiply the vector by some magnitude or by some number, you will get as result always a vector quantity. Here this one is the vector quantity. Remember, this one is also the vector quantity, 5 vector a, and this is also the vector quantity, my dear students. Okay, next lecture we will start the multiplication of any vector by the vector, that is the cross product and dot product. Okay, my dear students, you always remember, you have to recall me if you find any calculation mistake in my lecture. Remember, it could be the writing or the calculation error. Always remember, you have to notify in my comment section so that I can rectify for the further use. Okay, my dear students, thank you very much.